Swayam Prabha. Digital India. Educated India.
Hello, Namaste. I'm Dr. Abhinav Dhal from the Indian Institute of Technology, Ropar. And friends, this is week 12 in the Affective Computing course series. So till now, in this course, we have discussed several aspects about affect, how affect is perceived from a machine's perspective, how we can create a machine using different sensors which can sense the affect of a user or a group of users. We have also seen how the different data sets can be created and what are the different applications where affect can be used to have a more engaging, safe and productive experience for the user when the user is interacting with the machine. Now, what this also means is that affective computing slowly is becoming mainstream. So for a more useful and productive experience of a user with artificial intelligence systems, and with that be the very popular currently in 2023, the large language model kind of systems, it is important that after sensing the affective state of the user, the machine also replies back in an appropriate affective way. Now, what it also means is, as with any artificial intelligence system, a system which is trying to understand the user and then perform accordingly, there are some issues, there are some challenges which need to be taken into consideration before such systems can be deployed in the real world. And these challenges and issues are essentially around the very important aspect of ethics. So, how are the ethical boundaries they been kept in mind when affective computing systems are being developed, are being deployed, and what are the limits after which the use of such AI enabled systems can be counterproductive as well. So first we are going to discuss about the motivation, why ethics is important, and we'll see how, let's say, the concept of privacy that is being challenged, that is sometimes affected when we are trying to understand the affect of a user. Later on, I'm also going to share different perspectives with respect to sensors, with respect to the levels at which data is being processed, which is critical to the understanding of the ethical issues in affective computing. Now, this quote from Professor Picard, and I will read out for you, friends. The fictional message has been repeated in many forms and is serious. A computer that can express itself emotionally will someday act emotionally, and if it is capable of certain behaviors, then the consequences can be tragic. What we mean here is, after we have added the capability of understanding of affective state of the user into a machine and also have geared up the machine, we have taught the machine to react accordingly and have emotion. So once the machine will have an emotional persona and the actions of the machine are also affected by its own emotional state, which is driven by the external entities, which includes the user, where the machine is, then what effect can all of this have onto the user and the task which the machine is performing? Therefore, the emotional identity of the machine and the emotional response of the machine that needs to be very carefully curated such that the task for which the machine has been created, that is not hampered, and we are also taking into consideration the aspects about the user, the interest of the user, the safety of the user, and so forth. Now, first, we are going to talk about affective sensing, right? Understanding of the emotional state through different sensors. And friends, you recall we talked about how we can use a camera sensor for understanding of the facial expressions, body language of a user. Then we can use the microphone to understand the speech signal, and that gives us very vital cues about the emotional state. And then we have text and physiological sensors. Now, from the perspective of an affect sensing system, during its design, the designer's ethical and moral decisions, they are also embedded into that system. Now, a very fundamental question is, you are designing a machine which is detecting the emotional state of the user. Now, how would you decide which emotions the machine should be trained to recognize? Now, let's say the example is, you want to create an app which is analyzing the speech patterns of the user when the user is talking on the phone. So it's not actually looking at the semantic content of what the user is speaking, but essentially the pitch and fundamental frequency and so forth, so as to look at things such as stress. Okay. So the example is, you want to create an app which is going to detect stress based on the speech which is captured from the microphone in a mobile of a user. Now, if you want to understand stress, how are you going to define objectively the criteria? And then, what all emotions would you like to measure? Would those be the categorical emotions? Or you would like to go on to the valence, arousal, dominance, continuous emotion scale, so that you can map the speech pattern onto the state and then detect if the user is stressed or not. And further, if this app is created and is installed on a user's phone, how much is the user's understanding of what all the app is capable of? Is it just through the contract which the user has agreed upon? Or let's say there is a training phase as well, wherein the user is made aware of the capabilities of this app, and where we say, well, the app is going to measure the emotions so as to tell if during a certain point during the day when the user is using the mobile phone, if he or she is stressed or not. Okay. Now, once the machine is able to assess the stress versus non-stress state, which all entities within the mobile phone and outside the mobile phone are able to access that information? So, are there other apps which are installed on the phone? Are they being given access to the predictions which the stress app is making? Are there any outside servers, any cloud-based installation where the user's stress versus non-stress state is being communicated to? Because if you are going to store the emotional state of the user either on the device, then the method which is used to safely encrypt that particular data so that any malicious user cannot read the private information of the user, that would be required. Now, if you are sending the emotional state data to a cloud-based system, then one, what is the safety mechanism there? How the user's privacy is going to be maintained? Then other important questions are going to come into the picture. How long this data is going to be stored on the machine? And who all at the cloud end, at the server's end, is able to access this machine and then access this data? Do they have the rights to access this kind of emotional state data of the user? Further, once this is solved, where the data is stored and what are the security mechanisms around the data, the next question which arises, friends, is the machine has identified that, let's say, the user is feeling stressed. Okay, this is what the speech patterns are telling. Now, what will the machine do with that? What would be the patterns which would be analyzed That's first. And once those patterns tell the app that the user is stressed, what is the use case? What is the application of that? And who all are going to use that information? Is it just for the mobile phones user that they would, let's say, be given a feedback? They would be given an alarm that you can look at the longitudinal data throughout one day and see how your stress was varying based on the speech analysis? Or this is going to be shared outside with, let's say, a clinician as well. Now, since this data is critical, this is very much personal to the user. So after, let's say, the clinician accesses it, is the data being still stored at clinician's end? Is it at the cloud's end? So these are the kind of very important questions which are coming to the picture. Now, let's say once this is also solved, so we know from a designer's perspective that after the app is going to sense the affective state of the user, after we have discussed and decided where that information would be stored, what would be, let's say, the security parameters around that information, then we discuss what is the use, how are we going to use this information which we have gathered from the app. The next question would be, what would be the way in which the feedbacks will be given? Okay. So one example I've already shared with you, that the machine can show, let's say, a graph. Okay. So it could say, for example, from 6 a.m. to 9 p.m. This is how the stress, kind of varied upon. Okay. Are there other ways as well? This is quite explicit way. Are there implicit ways of conveying this to the user? What would be the right time at which this information should be conveyed to the user? And if at all, if the user is very stressed, should this information be conveyed to the user that you are very stressed? Or should there be a feedback which could explicitly help the user, let's say, in calming down? An example of this could be some suggestions regarding soothing music and so forth. Now, from the user perspective, the user would like to have control over these feedbacks as well. So as now an app designer, you will have to give these options to the user so that the user is aware about the whole gamut of how this data is going to be used and what all effect it could have on the user. And let's say if there are some pitfalls as well. So these ethical choices, these start at the designer's end. So the team of researchers who, let's say, are gathering some requirement and then would be designing a system which would be sensing the affect of a user. Now, when we are talking about affect sensing, these are the important ethical considerations, friends, which we need to take into perspective. The first is privacy of the user. Now, in the context of emotions, according to Professor Picard, are perhaps more so than thoughts, since these are our internal thoughts, these are our internal stage, these are personal and private. Okay. Now, should a particular machine be allowed to access this very private information? And what would be the particular use case within which it needs to be allowed, right? Not every app should be allowed to sense the user's affect, because not every app could be designed, could be capable of the repercussions of the future steps after which the affect has been predicted, because it's a very personal information. So personal information needs to be very carefully taken into consideration. Now, another interesting aspect is, so you designed this app which is understanding the user's emotion, and then let's say it is reacting by changing the color schema, the font of the user interface of the app. So now you could say that the interface of your app is also emotion aware, right? The app has sensed the emotion of the user, and then the response is also in the form of the visual changes which are there in the interface. Now, since the app has sensed and the app is now reacting accordingly, then is this also invasion of privacy of the user? Because the user has very personal thoughts and emotion is very personal to a particular person. So from the designer's perspective, it has to be extremely carefully taken into consideration that emotion, unlike simple attributes which are typically looked at a phone, for example, how many steps one has walked, right? Unlike this, emotions are far more complex, far more personal. The other important aspect which needs to be considered from the ethics perspective for affect sensing friends is the emotional dependency. Now, the question is as follows with respect to emotional dependency. If a user is using an app which is sensing the affect of the user and then giving feedback to the user very frequently, now the user might become dependent on to the app as well. Now, this one-way dependence, right, that could actually be unhealthy in some cases. And let me put this in a simpler perspective here. Let's say the user gets too dependent on an app for the feedback about their emotional state, and they are believing the emotional state result which the app is telling them. So that means their future action, their immediate future action might be influenced by the emotional state which has been communicated to them by this app, right? So they will get dependent on the inputs from this particular app, and that's a very fine line, friends, after which this dependency can become unhealthy. So again, from the designer's perspective, a designer who is creating an app, this is an important ethical consideration that the user should not become excessively dependent onto the app. Okay, you could also consider this particular point from the perspective of a virtual agent. Let's say the user is interacting with a virtual agent, a 2D or a 3D character, and the character is also able to sense the emotional state, and then the emotional response of the character and the personality of the character is tuned with respect to the emotional state of the user. So if with a longer use, the user develops a kind of relationship with the agent, the virtual agent, then the user will become quite dependent on the virtual agent. So, these kind of remote cases also need to be considered. Now, friends, the third point with respect to the ethical consideration in creating these affect sensing systems is emotional manipulation. So, after the machine has detected the emotional state, and let's say, the example which we were discussing about, the user being detected as feeling stressed, and then the app suggesting some music to soothe down, some soothing music, some relaxing music, and so forth, then isn't this essentially an attempt to modify the certain behaviors of the user? So in this pursuit of giving suggestions to the user, the app could eventually lead to certain behavioral changes in the user as well with longer, continuous use of the app. So is that actually healthy for the user? Could this create longer term problems for the user? So this needs to be taken into consideration while creating the systems for affect sensing. Now, another aspect is, you could say that the system is motivated by goodwill because the user was stressed and the machine wanted to help the user. So there is a good intent, but with longer and very frequent use, this may become counterproductive for the user as well. Now, the fourth aspect in the ethics consideration is building relationships. Now, in the very near future, a person who is using these affect sensing apps very frequently, at what point will that particular user begin to value affective computing technology and its well-being over another human being? So, consider a hypothetical scenario. A person is using an affect sensing app very frequently, and the affect sensing app is telling it, this is your emotional state based on, let's say, the valence arousal kind of continuous emotion representation. And the user gets so used to this that it is now dependent to get the feedback from the app for his or her own emotional state, rather than talking to or discussing any problems or getting feedback from the human beings around that particular user. So the effect of this particular user's relationship with his or her human beings around, his friends and relatives around, can in a very remote scenario these be affected if a particular user gets too dependent on getting emotional feedback from a machine and rather than not consulting with fellow human beings. So that's a very important aspect which needs to be taken into consideration. Now, from ethics, we are going to discuss privacy. Okay, the approach which we are going to take is as follows. So we'll say, well, your mobile phone is essentially a combination of a large number of sensors, right? So you have a large number of sensors, and these are collecting information in different formats at different frequency, which can be used to understand the affective state of the user. Now, we are going to talk about how these different sensors are capable, if not handled very carefully by an app designer creator, in evading the privacy of the user. So these sensors, friends, these are divided into three very broad categories. Okay, so these are based on their capability in privacy invasiveness intensity. So we have low, medium and high. On the lower end of the spectrum, where the chances of the invasiveness or loss of privacy of the user are relatively lower, are sensors such as your accelerometer, your battery, gyroscope, charger and so forth, right? Now, let's take an example. Okay, so you could use the accelerometer to understand the physical movement of the user, right? The aspects about the movement of the user when they are using the phone. And this could be linked to how much active they are, and that can be used to understand the affective state. Now, this could be a very loose correlation, but what we are actually getting is just the affective state. We do not get the information which is about the user. Who is the user? And other attributes such as age, gender and so forth about the user. So the personal information is still intact, let's say when you're using an accelerometer. Same goes for things such as your screen touch sensor and your environment sensor. So the pattern in which the user is interacting with the screen, so that tactile feedback, that pattern can be used to map to certain emotional state of the user. But still, that is it. It is not actually leaking, who is the user and so forth. Now, moving forward, the set of sensors which have a bit higher, a medium intensity for invasiveness in privacy of the user from an app perspective are the apps themselves. Some apps which are, looking at the browsing pattern of the user, okay, And then things such as Wi-Fi and Bluetooth sensors. So where is the user, right? So based on the Wi-Fi router network to which a user is connected, that gives very vital information about the user. Same is with the Bluetooth sensor as well. Being able to identify if there are other devices around the user also gives you information about the user. Right? Is the user alone? Is the user, in a group where, let's say, there are other mobile phones which also have Bluetooth sensors around. So, one could create metadata out of it. Now, from affect sensing, the most critical set of sensors with respect to the privacy concern are these ones. Okay. So, from the microphone, you can understand the speech. If you can understand the speech, not only you can understand the emotion, but using speech, one could identify the user as well. Essentially, who is the user? Is this user a male or a female? And then things such as, based on the speech signal, what could be the rough age group, right? So now, along with the emotional state, you are making the user very personal information accessible, interpretable. So that means if you're going to use the microphone in your app, in your software, you have to make sure that the user identity information that is essentially removed in the beginning of analysis of the data which is being captured. Now, same goes for the camera as well, friends. You are able to record the face. If you are able to record the face, you know who is the user. You again have these attributes like male, female, age, and so forth, right? So along the emotion, if you're going to use the camera, and since we are talking about mobile phone as an example, you could have multiple cameras, the front camera and the back camera. Again, from the privacy perspective, that's tricky, right? Front tells you about the face, back camera could tell you about where the person is, right? And who is the person with. So even though, the intent of the app could only be looking at the emotions through the camera, but if not carefully, created with respect to hiding the identity of the user, and if the security information is not very well maintained, this app could leak information, could be hacked and so forth. Now again, guys, there is similar GPS where the person is, call records, again very private information, SMS and emails tells you a lot more about, of course, the affective state of the user, how the user is, drafting emails, which tells us about the emotional state and so forth. But in the same pursuit, of course, the email or the SMS could contain very personal, very private information, which could be identifying the user as well. So what it essentially means is, from a effective computing enabled app or software developers, designers perspective, you have to be very careful in what all sensors are you going to use to sense the affect of the user, and in that very pursuit, be mindful of the vulnerability the user may have due to the app using these particular sensors. And of course, from the app designer's perspective, this would mean that you may have to do a trade-off between things such as how accurate your affect sensing is versus how much privacy aware your app is. So this is a very important trade-off. Sometimes you may make the app a little less accurate just because that may enable you to preserve the privacy of the user, which is extremely important. Now, moving on into similar direction, we discussed about the different sensors, right? So from the same example, which is analyzing the speech pattern of the user, let's look at the perspective of the privacy from an effective computing app's angle, from the different stages at which the information is analyzed, and what could be the challenges which are possible in these very states. Okay. So again, you have your mobile phone. There is an app which is analyzing the speech which uses the microphone. Okay, and the software is understanding the affective state of the user. So we are going to use the same example. So the four stages here, friends, are sensing, understanding, inferring the context. Once you have understood the context, then predicting the context, let's say the future context, future action, and then intelligent actioning, the feedback, and what could the machine do once it has understood the affect. Okay. Now you understand sensing would mean, friends, as we have talked about earlier, you are collecting the data from sensor, in our example from the microphone. What are the challenges? Well, this could be the quality of data which is being collected from microphone could be dependent on the sensor itself, onto the software which is being attached to the sensor, and also where is the machine being used. Now the machine, which is mobile phone in this case, could be, let's say, recording the speech samples of the user at a certain frequency, so as to look at how the emotional state is varying for the user throughout the day. Okay. Once this sensing has been done, so we have collected the raw data, comes the second stage, right, inferring context. So now this is your machine learning part. We are extracting features. So in the speech, it could be looking at your fundamental frequency and then extracting the MFCC or the representation learning pre-trained based features. So once the feature has been extracted, we are going to then use machine learning to predict. Okay. For example, you could use a Gaussian mixture model, or you could use a support vector machine, neural network, and so forth, which is measuring the stress of the user. So we have now inferred the state of the user. The next is, we have been recording the user and then we have predicted the stress versus non-stress. If we have sufficient data, it allows us to do predicting context. That is, we can build models for future events. We can predict how the user could behave at this particular daytime based on the data collected from the n earlier days, right? Now, in this, there are some very important questions with respect to privacy. If the user state is going to be predicted for a future event, how much the prior information is being used? Is that a short-term information, a longer-term information? What is the context in which that information is being used? And then again, the points which I was discussing with you with respect to who is going to get access to this future prediction. So you could use this prediction of stress level to do some type of feedback, some warning to the user as well, right? Now that would be your intelligent actioning. Perhaps when the user looks at the calendar and sees n events which are planned, the higher precedence event or the events which are just going to be happening in the very next few hours, those could be shown first, so that the user doesn't get a sense that they have, let's say, a very, very busy day ahead, right? But in this very aspect, the machine might anticipate that an event is X is more important than event Y, and then hence the visualization is showing that more. But perhaps it's not that particular way. Maybe one of the event is just a one-off event, and that is important for the user, right? The machine could then actually end up trying to regulate the behavior. Further, it's also a question of curiosity versus accuracy, right? As we have discussed with the sensor's perspective as well. What is the value of a decision, right? What is the cost if the prediction is wrong? And that again links back to the privacy concerns of the user with respect to how the app data is going to be used and who accesses and so forth. Now, there is a problem of insufficiency with respect to the current privacy approaches. So, current approaches, they use things such as cryptography, and then there is privacy preserving data mining approaches. Then there are approaches for anonymization of the data, that is removing identity information. It has been observed that these often are insufficient by themselves or in combination when they are deployed, right? So, even if the app predicted that the user is stressed and that longitudinal data is being stored in an encrypted way on the mobile phone, on the user's phone, there are still possibilities that that data could be hacked, that could be decrypted. What this also means is then after, let's say, the user has been given feedback about how they were feeling, how the machine sensed their affective state, is it really important to store longitudinal data? Is it important to store very fine-grained data because there are these privacy concerns? So again, this goes back to the designer, that if you're storing the information which has been predicted by a machine learning model, do you actually store the exact predictions, or some interpretations which could be used by the user in longer term but do not really affect or evade the privacy of the user as much as if the predictions themselves were stored and unfortunately there was an unaccredited access to that data. Now, with respect to anonymization, right, which is removing the identity information, it's fairly complex to anonymize data because it's non-trivial to have a foolproof anonymization method. It has been shown in recent research works in signal processing and machine learning that how, for example, the pattern of key press on a keyboard or on a mobile phone can be used to roughly identify who the user is. Further, things such as using the Wi-Fi signal, using the radio, the radio signal in turn can be used to look at how people are, let's say, walking or are doing certain activity in a room, right? So one can deconstruct the identity information or some vital information about the user from the sensor data, even though a designer may think that the sensor data is not recording the identity information, the personal information of the user, but with these newer mappings which are being enabled by the deep learning based systems, one could make sense of the private information which, let's say, is captured from the Wi-Fi signals or from the accelerometer plus gyroscope kind of data, right? So what this means, again, this is the whole discussion goes back to the designer themselves, that they need to be very careful, observant of this fact that even though they are trying to anonymize the data which, let's say, is going to be stored or which is going to be analyzed at a cloud server and to predict about the user's affective state, there are possibilities that the identity or a pseudo identity or a smaller set of attributes which are still extractable from that data which could identify the user and hence affect the privacy of the user. So friends, in this first part of ethics in effective computing, we discussed aspects of why it is important to consider the different gamut of ethics, how the sensors can be used to understand the personal data, which from a designer perspective is extremely important to know so that they do not affect the user. They design the machine such that the privacy of the user, the ethical concerns which we have with respect to the affect sensing and affective feedback, they are taken into consideration. Thank you.